So let's take a look at the things I forgot to look at the end of the last video. So domain for the cotangent function, notice how the asymptotes are at 0 and pi, and the period of the cotangent function is the same as the period for the tangent, so that's pi. So the domain is x cannot equal multiples of pi. Vertical asymptotes, of course, occur when x does equal multiples of pi. And the range is all real numbers. Again, the graph extends from negative infinity up to positive infinity. Taking a look at transformations for tangent and cotangent, the tangent function, again, the shape is like a snake over and over and over. The asymptotes will occur, so it's kind of like when we found the left endpoint and the right endpoint for the sine and cosine. We're finding the asymptotes, and then the snake graph will be in between the asymptotes. So you would set what's in the parentheses equal to negative pi. Remember, when we graphed tangent, we graphed from negative pi to pi over 2, and that was one full snake. The right endpoint will occur when you set what's in the parentheses equal to positive pi over 2. The period, similar to sine and cosine, except for the period of the tangent function is pi, so we take pi divided by b instead of 2 pi divided by b. So be careful that you don't get into the habit like we did with sine and cosine. The period for the tangent and cotangent is pi, so when we do the horizontal stretch or compression, we take pi divided by b. And the vertical shift stays the same, that's the d value. Cotangent is similar, the difference is those asymptotes occur at 0 and pi instead of negative pi over 2 and pi over 2. So when we find our new asymptotes for the cotangent function, we set what's in the parentheses equal to 0 or pi. So you need to be very careful which function you're graphing so that you know how to find the correct asymptotes. Everything else for the cotangent function is the same. So let's start with the transformation. We've got the tangent, so remember these parent function asymptotes occur at negative pi over 2 and pi over 2, so that's how we're going to find our new vertical asymptotes. Identifying the information in this transformation. Our a value is negative 1, so we have a reflection. Our b value, what we're multiplying by the x, is 2. So we do have a change in the period. Our new period is pi over 2. And our d value is 4, so we have a vertical shift of 4. So finding that left vertical asymptote, we set what's in the parentheses equal to negative pi over 2, and we solve for x. So adding that pi over 4, getting a common denominator, the negative pi over 2 becomes negative 2 pi over 4, plus pi over 4 gives us a negative pi over 4. And dividing by 2, remember when you divide a fraction, it goes into the denominator. So that 4 times 2 in the denominator becomes pi over 8. So we have our left vertical asymptote will occur at negative pi over 8. To find the right vertical asymptote, we do the same thing, but we set it equal to positive pi over 2. So when we turn that into a common denominator, we'll have 2 pi over 4 plus pi over 4. So 2x equals 3 pi over 4. And again, when we divide by 2, it goes into the denominator with the 4, and we get 3 pi over 8. Make sure you have those vertical asymptotes down, as I need to erase that work in order to get our graph sketched. So pause the video here if you don't have those down yet. So I scaled the x-axis for us. I marked it in terms of pi over 8 because that was our shift. And what happens for the tangent function, if you think about the parent tangent function that we graphed, in the center of the snake, it was 0, 0. Halfway between 0, 0 and the asymptote, it was 1. So at pi over 4, that was halfway between 0 and pi over 2, it was at 1. And halfway between 0 and negative pi over 2, it was at negative 1. So those are the three values that we're going to use to plot our transformations. And then because we know the shape is a snake, we can get the rest of it graphed from there. So the tangent function has a reflection. So instead of the normal cubic where it goes up to the right, this will go up to the left. So starting with sketching in those asymptotes at negative pi over 8, 3 pi over 8, and again, 4 units off to the left, so I'm going to sketch 2 periods on this one so you can kind of see that repetition that we didn't get to see when I did the parent function. So we need to scale our y-axis, and we have a vertical shift up 4, so I need to scale at least until 5 because we're going to use that 1 as a marker for our tangent function. And we really don't need to go down at all because we just need to go up 1 and down 1 from our new x-axis, which was shifted up 4. So I'm going to sketch in a new x-axis at 4 as well. All right, so that's our new x-axis. So when I plot an intercept or a 0, 0, that's where it will land. So halfway between my negative pi over 8 and my 3 pi over 8 is at pi over 8. So that will be my intercept. At pi over 4, halfway between my intercept and the asymptote, I'm going to go down 1. Normally the tangent function goes up to the right, but with the reflection we're going down to the right. And then at 0, halfway between my pi over 8 and negative pi over 8, I'm going up 1. And then what you do with those 3 points is you just sketch that snake-looking graph. We're going to do that again over off to the left. Again, we're going to sketch one more period. So halfway between the asymptotes at negative 3 pi over 8, that will be my intercept. Halfway between that one and the asymptote, you go down 1. And halfway between that and the other asymptote, you go up 1 and you sketch your snake. All right, and last we've got our cotangent function. So again, identifying all of those pieces of information, we have a stretch this time of 2. If we have a vertical shift, which we do on this one, once we find our new x-axis, we will go up 2 or down 2 from that axis because of the vertical stretch. Our b value is 1/3. Remember the period of the cotangent is pi, so we're going to do pi divided by 1/3, which is the same thing as multiplying by 3, so our period is 3 pi. And our d value, as we mentioned, we're going down 1. So to find those asymptotes, remember for cotangent, the parent function asymptotes are at 0 and pi. So we are going to set 1/3 x plus pi equal to 0 to find our left vertical asymptote. So we have 1/3 x equals negative pi. Multiplying both sides by 3 to cancel that division by 3, we get a negative 3 pi for our left vertical asymptote. Do the same thing for the right vertical asymptote, but set it equal to pi. When we subtract pi, we get 0. And when we multiply by 3, we still have 0. So we've got a left vertical asymptote of negative 3 pi and a right vertical asymptote of 0. So when we scale our x-axis, we need to do the same thing, dividing the period by 4 in order to get the correct scale. So this one, our period is 3 pi, so we divide that by 4, and we're going to be counting by 3 pi's over 4. So then we'll have negative 6 pi over 4, which simplifies to 3 pi over 2. And then we'll have 9 pi's over 4. So just adding 3 to that numerator, and then 12 pi over 4 simplifies to that negative 3 pi. And we'll have those same values off to the right. Scaling our y-axis, we need to go down to negative 1 for our new x-intercept, and then down at least 2 more from there for that stretch. Then we'll have to go up 2 from our new x-intercept as well. So now I'm going to sketch in those asymptotes at negative 3 pi, at 0, and then we'll see one more period off to the right on this one, so we'll have another asymptote at positive 3 pi. Then I'm going to sketch in our new x-axis along that negative 1 line. All right, halfway between our two asymptotes, we will be at 0. So that'll be at the negative 3 pi over 2. Going over 1 and down 2. And going over 1 and up 2, we can get our snake-like function. Doing the same thing for another period off to the right. Halfway between the asymptotes, we're at our intercept. Over 1, down 2 for that vertical stretch, and over 1, up 2 for the vertical stretch. And that is how we graph transformations of tangent and cotangent. So again, for your UTRI problems, write your questions and a summary.